Alright guys, welcome back to my channel with a horror upload cycle. Today is the first time I actually am using a script right now. I'm also kind of sick, which is why I have the time to make this video. Yeah. So I'm not going to make lines on the spot, or at least I'm going to try not to, because, yeah. And, yeah. Today we'll be talking about how computers use binary. So, let me write this down real quick. So, how computers use binary. Wow, this is killing my computer. So, your computer is a bunch. Oh my god, that's a horrible line. Oh my god. So, your computer are a bunch of lines. Let's say we're talking about a 4-bit computer here. Let's say your computer has like 4 lines. Or not even computer, just 4 lines. These lines can either be on or off. On or off. When it's on, it carries the value of 1. When it's off, it carries the value of 0. If you watched my past video on binary explained horribly, then you would know that this is how this is binary. So let's say on, off, on, on. That is 1, 2, so 3, 4, so that's set as 0, and then 8. So this would be 12. No, it would be 11. I can't think. It'd be 11. So just using a bunch of binary, yeah, you can represent numbers like this. Computers use like binary at the hardware level, just like this. This is because your computer is made up of literally a bunch of on and off switches that I just showed you, except they have a bit more condition to them. A transistor. So I'm going to draw a transistor like this. It needs a signal, which when allowed, and then it needs an input. When this signal is on, it allows this guy to send a signal down here. When this one's off, or when this one's on too, that sends a signal. 1. When this guy's off, this guy closes, even if that one's on, becomes 0. This can be used to create a number of stuff, like Boolean logic gates, which can be built into more stuff to make arithmetic logic units, which is what your CPU uses to do math. Math is a pretty integral part of computing. I don't really want to tell you why. You can probably find like a 3 blue 1 brown video or something. Or no, I don't know. You should probably just look it up. How does your CPU work? And you'll probably find a video on it. I'm too tired to do that. Yeah. Your CPU has a stack. So let's just get rid of everything. Your CPU has a stack. I'm kind of going to go into CPUs a little bit. A stack. So, usually like 1 megabyte or something. So this is a stack. Let's say you have a bunch of tasks. Okay? So when you program in C or C++, and you don't use and you just write int x equals 12, for example, this would be using stack. You would put this value into stack. When you use pointers, it would instead put it into RAM. RAM is basically so if you're on a laptop, this explanation will work for you because you can't look into your computer without opening it up. Chances are, if you're watching this course and you want to learn about it, you learn about computers and you're not good with computers, you really shouldn't open up a laptop. They're really dense. I opened up my laptop before and almost killed it. Please don't be like me. Don't be stupid. Please. So when you said, so yeah, this is RAM. I don't know how to draw the contact. So this is your RAM. So if you use pointers, I kind of like too lazy to use pointers. So we're just gonna say pointer. Fine, we're gonna say int. I'm 12. Give me a break. So we're gonna say pointer example. When you use pointers, it goes into RAM. So we're gonna write this. We're gonna go RAM stack. And your computer also has an ALU. So we're gonna draw a little box over here. We're gonna call it ALU. ALU. This is the math zone. It also has some bitwise operations, like AND, XOR, that stuff. You can probably, again, just look up a 3 blue 1 brown video on Boolean algebra. If he didn't make one, which I'd be surprised, you can just look up how does an ALU work. Even just watching like a redstone, like even a Minecraft redstone ALU, that still works. That's how I learned my computer garbage from redstone in Minecraft. So yeah, the ALU just does math. So it takes inputs and then gives outputs. That's an ALU for you. Yep, and just math stuff. Don't question the ALU, it just does stuff. So, let's say we're going to do 1, 0, so 1 plus 2. It would give you the answer 3, so it would be 1, 1, and then just leave this blank, but that can be considered a 0, because by default, when it's off, it's just a 0, so 1, 1, 0, which is 3. You also kind of have to tell you're doing addition. But yeah, I'm really tired. Yeah. What was my note say? Most modern CPUs as well, like, have cores. Like, I know any CPU in the world has a core, a processing unit that does math, kind of like this ALU. Most modern CPUs have like 2 or more cores. Let's say these are 2 cores. Usually there's a bit of space between them, so boot much better. Just get a thumbs up in real life as if it was like the game was on. It's so stupid. Such as like my i5 6300U, i5 6300U. We'll go into the details of Intel CPU naming and then Ryzen CPU naming. We're doing Intel first because I'm targeting for the platform that I use first. One day, maybe one day down the line, I'll do a Linux tutorial, but again, that's when I actually decide to switch. But actually, real modern CPUs, not like 2015 CPUs, have like 6 cores. Lucky guys. Like a Ryzen 5 3600, for example. My Steam game just finished downloading. Ooh, cool. I'm gonna check out the game. Yeah, so let's say these are 6 cores. They can do parallel processing. So let's say we have a large stream of data on just 2 cores. Each core would take a lot, especially on a CPU old enough to have only 2 cores. It's gonna be really slow. On a CPU new enough to have 6 cores, meaning each core can not only do more stuff, there's also more of them to take more of that work away from each one individually. It's just less crowded. And then, so these guys having, or could they just get overheated, especially on a laptop? Because I'm just going to think of, not even on laptops, it's going to get hot when it tries to do stuff. Because your CPU, let's clear up the screen, your CPU has a clock speed, or instructions per second. Show a delete. And I need to select everything out of the way. Get out of here. Okay, so your CPU has clock cycles, your clock. So my CPU is 3.1 gigahertz turbo, 3.1 billion instructions a second. However, it's a laptop, so it never really reaches above 2.8 or 2.7 because laptops are tiny. You can fit an entire laptop inside of your water cooling tower. So yeah, because when electricity passes through a CPU or anything really, it creates heat. So when you're trying to put electricity through faster, guess what? More heat. So even if your laptop technically had better specs than a desktop, not only is laptop hardware nerfed, because again, the laptop cooling system is too tiny, even then, it's still inadequate to cool anything. So yeah, that's why on most gaming laptops, you notice the temperature slowly rising. That's especially if you have like a 4070 or like a 3080 Ti or something crazy. because even the 4060, which is still awesome, by the way. I wish I had a 4060. I wish I had a 10. I wish I had a 1060, bro. Oh, regardless of dream, ignoring my hopes of a decent laptop. Yeah, gigahertz. We could just, so yeah. So the more accurate term is higher clock, higher heat. But yeah, let's get rid of all of this stuff. And then now this is here. Actually, I'm gonna need to control A. Get away from get out of my face. Okay. But some CPUs actually have one core. The most prominent example I can think of that is still 64-bit is the Intel Pentium 4. I'm stuttering so bad. What the hell? The Intel Pentium 4. What is the Intel Pentium 4? It's Intel's first 64-bit CPU, I think. Yeah, 64-bit CPU. Barely. Because I don't think it can run... Actually, technically speaking, you can run Windows 11 on your Pentium 4. But I really wouldn't... Because let's say you have a huge workload. You have one core where all of that's going. Also, just to clarify, cores aren't just one process here, or aren't just one thing. They have threads. Let's just say these are threads. With Intel hyperthreading, one core has 2 threads. You can double your core count, technically speaking. But yeah, I have 2 cores, 4 threads. But yeah, so this thing has 1 core, 2 threads. So to go onto those 2 threads, overwhelming the CPU. And since the Pentium 4 is really hot, because it's old and inefficient, because remember, when heat passes through something, or when electricity passes through something, it makes heat as a byproduct. So yeah, when you make something with a smaller node, production node, let's say 7 nanometer, it's smaller and takes less power, meaning it makes less heat, meaning you can buy a cheaper power supply that doesn't do as much, have as much power. Also, you can buy a cheaper cooler. Also, gives better overclocking and stuff, and efficiency stuff, and I don't know, man. I'm tired. Leave me alone. I will not be covering GPUs in this one, although I really wanted to. When I was designing the notes, I realized that I want to make my own video for them because I think they're so cool. GPUs and embedded programming are my favorite parts of programming. Don't judge me because I forgot how to use pointers due to the fact that I took a long break from programming. I had 3 tests this week, okay? This is the one day I have no tests and I'm sick enough to stay home. And yeah. I also really suck at everything I do in programming. I'm like an ace of all, or a jack of all cards. Whatever. Okay. Let's say, screw you, hardware. I'm actually a software guy. It's not better. The grass is not always greener on the other side. It's still pretty complex. Yeah, I really am just dying right now. So yeah, computer programmers in the past. I'm gonna read my notes instead of improving this. What the hell? Yeah, at the software level, computers don't understand your code. For an example, printf. Let's imagine we had int main up there. Printf. Hi. Your CPU doesn't really understand this. So we're gonna go CPU. What the what is going on over here? What is that? What the hell is that? I don't even know how to read that. So the compiler / interpreter, this is C code, so it's compiler. I'll go more in detail into that next time, hopefully. It's compiler, and then it spits out an object file, and then it spits an object file, and then it spits out an exe. Yeah, editor's notes here. The entire part of the video where I explain machine code is just gone. It's not in the recording. I'm not gonna do that again. So I'm gonna finish editing this video, and you can look up how the CPU understands machine code. And yeah, there's no proper outro anymore. So this is my outro. Please subscribe. I have no incentives to make these videos. If you give me a community, I'll possibly consider making a good upload schedule. I want 10 subscribers, please. Actually, even just 1 subscriber lets me know that somebody likes what I do. Because I got 12 views on the last one, but no subscribers. That made me sad. Really sad. Like, oh my god, you're too lazy to subscribe. Like, please, bro, if you like the video, please subscribe. I hate. I'm so tired, bro. That's for the 17th time, bro.